So for this question, the example that they, excuse me, in the book is on that Lippmann book, page 421, where they walk through it. And all we really have to do, they go through the big explanation where this formulas come from, but that's what we're going to do. It looked like you were able to do maybe part of that, but so here's what we did. So we're given this information. And what we want to be able to make the connection of is that negative 2 corresponds to that m in the formula. The positive 2 corresponds to the n in the formula. And the bx is the argument. In this case, the b is just going to be 1, so we don't have to worry about that. And we're just going to walk through this. So what I did is, from the problem, I looked at this formula here. In order, this is a squared equals m squared plus n squared. So I just pulled the numbers out of what they gave us, and I got 8, and then of course the square root of a will be square root of 8, which implies 2 root 2. It looks like we could just give this as a decimal with my open math, and they'd take either the radical or the decimal. Okay, and then in order to find the shift here, we're gonna use this part of the formula. We know that the cosine of c is the same thing as the m number divided by the number we just found, which I rationalized that to root 2 over 2. And then I did the same thing with the c just to see what that value was. What's important to note is that if the cosine's negative and the sine is positive, then we know that this has to be in quadrant 2, because that's, remember, all seniors turn crazy, or all students take calculus. That's how you know what's positive in which quadrant. So I know in order for the cosine to be negative and the sine to be positive, it's got to be in quadrant 2 here. So how do I know what angle to use? I know, because then what we're going to do is, I didn't write this part down. If we're going to do the arc cosine or the arc sine of root 2, isn't that pi over 4? So you had written that, but since it's in quadrant 3, we know this reference angle is pi over 4. So that tells me that has to be 3 pi over 4, because it's pi minus 1/4 pi, right? And that's what those decimal equivalents are. Now this problem, it's the same section. We could rewrite this in terms of that same formula we just used in that other problem, but there's nothing saying that we couldn't graph this and find the answers, and being able to work with a calculator is an important aspect of AP Calculus, certainly. So all I did is I could do this with a graphing calculator. I also chose to use the Desmo website because that makes nice, pretty graphs. So I just put the left side in y1, I put the right side in y3, and found the intersections, and notice those are exactly the same answers. Okay, that was easy enough, I hope. The thing to remember for this year is, if a problem says solve it analytically, that means don't use a calculator. If they don't say, if they just say solve it, they're assuming you can use a calculator. So looking at this one, when they tell me that I should use this model, that's looking like the exponential growth. So if you look on page, or the exponential midline. So if you look on page 442, I think is where I got this picture from. What they show in the example in the book is just to use values, substitute in values from the table into that model, and you'll be able to come up with an equation. So what I did is I looked at this model, and I said, okay, so what happens when x equals 0? So I replaced y is 2, right? So I replaced y with 2, and any b number times 0 is going to be 0, and then I replaced 0 in for t in this exponential part. Well, the sine of 0 is 0, so that whole first term drops out. B to the 0 is 1, so that tells me a is 2. So that solves the first part of this question. That left me with this part of this equation looking like this. So I knew that the initial term, the initial value of or the place where it crosses the y-axis is at 2, or yeah, it's at 2. So then I just pick the next point, 116. So if t is 1 or x is 1, that's there, and then y is 16. I know that the a number is 2. So, and they told me this, that the coefficient of the x is pi over 2. So pi over 2 times 1 is pi over 2. The sine of pi over 2 is 1, so a times 1 is 1. And then 2 times b, I can't do much else with that right now, so I left it. I have 2 variables. It tells me I might need to have 2 equations and have a system of equations. So I substituted in 2 and 72. Y was 72, b was 2. Pi over 2 times 2 is just pi. Well, the sine of pi is 0, so that whole term is gone. Leaves me with the 2 times b squared. So divided by 2, I got 36. I took the square root. I'm going to just work with 6. I don't have to worry about the negative 6 root, right? So since b is 6, I can come back into this equation now, use the substitution. 2 times b is 12, or 2 times 6 is 12. Subtract 6, you get 4, and notice that is what they're telling us for answers. The a is 2, we found that here. We found out that b was 6, and we found out that a is 4. So that's how you do it. I mean, calling back stuff from Algebra 1. Just in a little bit different context. So for this problem, we're going to apply a couple of different trig identities to it. I noticed to the 4th power bothers me because I haven't worked with any 4th power problems, and I haven't seen any 4th power identities. So what I'm going to do is I'm going to rewrite this in terms of sine squared squared, because you remember you multiply the exponents when you're raising a power to power. Now what's nice about this is then I can apply this power reducing formula to that. So I'm going to think of this as 1 minus cosine of 8x, if the alpha is 4x, 2 times that is 8x. All over 2. Squared. Well, I can deal with squaring a term. So I'm going to square the numerator. And I'm going to square the denominator. Now I'm going to have to FOIL that numerator. So 1 minus cosine of 8x times 1 minus cosine of 8x. Well, if I FOIL that out, I'm going to get 1 minus 2 cosine of 8x plus the cosine squared of 8x. And remember, this is all over 4. So since it is all over 4, I can break it out this way, which gives me 1/4 minus 1/2 cosine 8x plus 1/4 times. Now here's the issue. Since this is another squared term, and that isn't what they're giving me in the formula that I have to substitute in, I have to break this down a little bit more. So I'm going to use that other power reducing formula for cosine squared, and that's going to give me cosine of 16x plus 1 all over 2. Well, if you bring that 2 out, that's going to give you a 1/4 minus 1/2 cosine 8x plus 1/8. Let's see. I'm going to change my gears here. I'm not going to pull that 2 out. What I'm going to do is put the 1/4 through and then break it out to 2 fractions. So that gives me the cosine of 16x over 8 plus 1 over 8. So then I get these two like terms here, which becomes 1/4 plus 1/8 is 2/8 plus 1/8 is 3/8 plus 1/2 cosine of 8x plus 1/8 cosine of 16x. And I believe that's what the answer was. So how do we tackle this kind of problem? Well, I know that cosecant is the same thing as a reciprocal of the sine. So if the cosecant's 8, I know sine x is 1/8. And they're telling me that this angle is between 90 and 180, so that's in quadrant 2. So I know the opposite side is 1, I know the hypotenuse is 8. So that tells me this side has to be a squared, what is it, a squared, c squared minus a squared or whatever. So 64 minus 1 is 63, squared is 63. And since it is in quadrant 2, the x coordinate, the x-axis is negative. So it's negative root 63, or negative, let's see, 9 times 7 is 63, which is 3 root 7. Okay, so then we got to apply that half angle formula. So that's what I did. I wrote 1 minus, well, if the cosine, since the cosine of this angle is negative 3 square roots of 7 over 8, negative turns positive. Okay, and then I wrote it out just to make it look like what they had there in the problem. I mean, you could also just grab a calculator, crunch this, divide by 2, take the square root. What they did, in case some of you are having problems with this, they just pretended this is like 1/2 times 1 plus 3 square roots of 7 over 8. Just a little bit of fraction work. Okay, so that's how they came up with the sine answer, and that does check if you check in the calculator. So for the second part, now we're talking about the cosine, cosine of a half angle. So same setup, same triangle, quadrant 2, and I just applied these values to this formula, and it works out to be that. Now, there's no place in the book that talks about the tangent of a half angle, so what they're asking you to do is to remember that the tangent of an angle is the same thing as the sine of it divided by the cosine of it. And if you take these two values, you get that 15.9. Okay, so I hope that helps. Alright, so to solve this, I mean, graphing on a calculator would certainly be an option. It doesn't say solve it analytically, so that's a possibility. This one isn't too bad, though, analytically. What I did is I wanted having a cosine squared and a sine was troublesome, so I thought, oh, well, let's use that Pythagorean identity. Cosine squared is the same thing as 1 minus sine squared, and then I just replaced 6 times this, and that's where I wrote, then I used the distributive property to get 6 minus 6 sine squared plus whatever plus they gave me, what they gave me already. And then I combined like terms, came up with this. Well, this factors very nicely, which tells me, both use the zero product property, which tells me the sine x equals 2/3 and sine x equals 1/2. So then, let's see here. I found the arc sine of both sides, the arc sine of that, which is this, and I found the arc sine of that also. Now, I know the sine is positive in quadrant 1 because of all and students in quadrant 2. So that tells me that this reference angle here, this arc sine, using the arc sine, that is what that reference angle measures. Now, since I want to account for all possible solutions here, and in that range, it said 0 to 2 pi, that angle here is also that 0.72 whatever. So I get to find that angle, which is this angle of rotation. We have to do pi minus that reference angle. And I did the same thing with this other angle. I know the arc sine of 1/2 is pi over 6, which is that decimal equivalent. So same deal. Since it's positive here, it's going to be positive here. If that's pi over 6, that reference angle is pi over 6, which tells me this angle is pi minus pi over 6, which is 5 pi over 6. So and those are the decimal equivalents in the answer. So that's how you solve a trig equation. Okay, you would get similar answers, or the same answers if you graphed it. You would want to say, if you wanted to do this graphically, you would have to put, you could just put this in your calculator. Then since it's equal to 0, just look for where it crosses the x-axis. Make sure that you're looking at 0 to 2 pi, right? So you'd only want answers in this range. Okay, so to solve this problem, you certainly could do this out with a calculator. I didn't set that up, so I'm not going to do that now. You would put this in y1, put this in y2, look for where they cross, make sure you're in that range. Okay. To do this analytically, I knew that, well, I set it equal. I'd have to get everything on the same side of the equation, right? And then having cosines and sines in the same equation is a royal pain. So I remembered the Pythagorean identity, right? So I can solve that for cosine squared. And what I did then, I replaced that in this, which gave me that. See, that's the cosine squared. And that's what they gave me. I just brought it to the left side. Then I made the leading coefficient positive 1 divided by -1. Right? Nothing new there. That doesn't change anything. And then this doesn't factor, so I need to use a quadratic formula. I'm not using the quadratic formula on this, so I use that Quad 83 program that Mrs. Bruckner gave you last year. Or you can use an app. The app gave me these two solutions. Since the sign has to fall between -1 and +1, I know this is an extraneous solution, so I'm going to throw it out. I found the arc sine of that decimal value gave me that reference angle. Now what you got to remember is that the range of the arc sine is from -pi/2 to +pi/2. But that's why it gave me a negative answer, which is that reference angle, right? I mean, really that just becomes a reference angle now. And since they want answers between 0 and 2 pi, there's the first one. Well, if the reference angle is this decimal here, it's also going to be over here, right? The other thinking, I'm glossing over something. Since sine is negative, I know the sine is negative in quadrants 3 and in quadrants 4. So that's the other reason why I drew those two triangles there. Okay, so to get the angles that's in that range, I went pi plus that reference angle, and 2 pi, right? I got to get this reference angle, or this triangle, I'm sorry, this angle here. That's going to be 2 pi minus that reference angle. And that's how we come up with those answers. So how do you write an equation from a word problem? That's always a problem, isn't it? So what I did, and what I do when I have to tackle these kind of temperature questions, what are they telling me? It's telling me it can be modeled with a sinusoidal. I know that the high temperature is 72, so I drew this dotted line representing the high temperature of 72. And the average temperature is 60, so that's there. And then, since I know this is a sinusoidal, if that's 12, if that's a distance to 12, this has to be a distance to 12 also. So 60 minus 48. And then I know that sinusoidals have these turning points, right? And I know it's a 24-hour period in a day, because it's going to go from the maximum low to the maximum, back down to the low, right? So what I did is I marked 4 lines here, divided the 24 hours into 4 parts. That's where I got the 6, the 12, 18, and 24 from. But they're telling me there's a shift going on here. They're telling me that the high temperature happens at 4 p.m. Well, 4 p.m. is 2 hours to the left of 6 p.m. and I know that's the high temperature. So I marked it 16 just for myself, for my reference point. Then I marked that shifted function, right? So this would be 4 a.m. That would be 10 a.m. That would be at what did we say? 5 p.m. I'm sorry, nope, I'm looking at the wrong question here. That's 4 p.m. And then that's going to be what, 2200 hours, which is 10 o'clock at night. And we don't know about the, I mean, I don't really care about the coming back down. I could, it wouldn't be wrong to. So what I'm seeing here, I'm seeing a shifted cosine function. And I also see this been reflected, because typically cosine functions start up and come down to the midline, then go down, right? Well, that's not what's happening here, so it's been reflected. So I know the amplitude is this distance here, that's 12. So I can write negative 12 cosine. Now, since the period is 24 hours, and we know normal cosine graph is a period of 2 pi, I can write that as 2 pi over 24, pi over 12 was what I'll write eventually. Now it's been shifted. Typically all these cosine and sine graphs happen on the y-axis, so this has been shifted to the right 4, so I'm going to do, so here's another temperature problem. So set up the same setup, my 4 turning point, 24 hours, they're telling me it can be modeled with a sinusoidal. And we know it varies between 43 and 77, so I'm seeing the minimum and the maximum. They aren't telling me the average in this problem. So there's 43, there's 77. Let's see, what is that? That's a distance of 34. So half of that's 17. So if I add 17, which tells me the amplitude, by the way, right? Add 17 to 43, what is that, 60? So the average temperature is 60. I know the amplitude is 17, I said. And let's see, the average daily temperature first occurs at 9 a.m. Well, 9 a.m. is halfway between that, so average occurs there. So that's the maximum, because remember, temperature, it starts off low, cold in the morning, average, maximum. Then it comes back down to the average, and then sometime after 24 hours would be back in the minimum, but we really don't care too much about that. So I'm seeing another shifted, reflected, shifted cosine function. We know the amplitude is 17, we said, so negative 17 cosine. And we know the period is 24 hours, so 2 pi over 24. We know this is shifted to the right, let's see, when at 9 a.m., so that's 3 hours, so we're going to shift it to the right of the y-axis by 3 hours, and then the whole mess gets shifted up to 60 degrees. Okay, so then how many hours after midnight? To 2 decimal places, the temperature first reached 56 degrees. Well, we could certainly put this in a calculator. In fact, that's what I think I would do. I would put this into a calculator, and then I would put in Y2, I would write 56 degrees, and then I would see where the intersection is, the first intersection. Okay, hope that helps. So, for this one, we get a Ferris wheel problem. I think you probably did some of these, Mrs. Bruckner. So we know they're telling us that it loads 4 meters above the ground. So I drew a circle to represent the Ferris wheel. They're telling me it has a diameter of 40, so the radius is 20. It takes 2 minutes to go all the way around. So half a minute in, it's at a quarter turn, right? So 0, and then at a minute, it's at the top. A minute and 3/4 is back down to that point, and then after 2 full minutes it's back down as the 4 meters high. So now what I did is, if the radius is 40 meters, I added the 4, that's where I got the 1, 44. A half a minute in, it's at the radius plus 4, so that's 24. And then a minute and a half into the ride, it's back down to 24. So now I've got these points. Let's graph them. So 1, 2, 3, 4. That's 2 minutes. That's 1 minute. That's 1.5. That's 0.5. We know it starts out at 4. The midline's at 24. It maxes out at 44. So we're starting at 0. It's at 4. At half a minute in, it's at 24. A minute in, it's at 44. It's back down to 24. Back down to 4. I'm seeing a reflected cosine function that's not, see, here's the midline, that's not shifted left or right. So the amplitude is going to be the same thing as the radius. So negative 20 cosine, and we know that typically cosine functions have a period of 2 pi. This has a period of 2. It's not shifted left or right, and the whole thing is shifted up to the midline of 24. So then what we're going to do is put this equation into y1, put 27 into y2, and you're going to look for how long, see what we're doing here, let me go to a different line. You're going to be looking, this is the line y equals 27. You're going to be looking for that intersection point and that intersection point. And then what you're going to do is you're going to subtract those two answers, and that's where they're going to see. They're asking how many minutes has it spent higher than 27. So you'll find that answer, you'll find that answer, and then you'll subtract the two, and that should be the 0.9 minutes. Okay, which would make sense. It's only a 2-minute ride all the way around. So I hope that helps you out.